Hello. So today we're going to discuss how to create a tree or canopy height model using Cloud Compare and some laser scan data. This data is going to be from a drone-based laser scan, specifically using the DJI L2 laser scanner. This has already been processed from how it was collected, the files that were saved to the drone using DJI Terra, and the output file, which we will need to start with, is always going to end in a .las. This is the most common file type for laser scan data. To get started, we'll need a copy of this file, and we'll also need Cloud Compare. So Cloud Compare is a software that is free and available online. Here we're using version 2.13.beta. This is from October 15th. So this is a very fresh release, actually just a few days ago. It can be found and downloaded online at www.cloudcompare.org, and it is available for commercial use. So to begin, we take the laser file and we simply drag and drop it into the main black window of Cloud Compare. When you see the notification come up that you have here, this is asking you what you would like to bring in along with that data. So the laser scan data has a few other pieces of information which are contained within each specific point. Intensity is the intensity of the laser return. The return number, of course, on a laser with multiple returns will indicate which return, one of many, it would be. The number of returns for the data sets, everything should be the same since it's from the same laser scanner, and any classifications that have already been made. So these are any filtering of the data that's been done in post-production. At this point, this is an unclassified cloud, so we don't believe anything to be there. And then finally, another useful one is GPS time. This shows us the time which each point was collected at based on the GPS on the device. This is useful for determining the path that was taken. Sort of like a trajectory, but without having the trajectory itself. So we're going to leave all of these on. They're on by default. And we're going to do all the basic settings that we have here. We're not going to touch anything else. And we're going to hit apply to all. This next prompt is also default and comes up every time. Essentially, it's going to scale the coordinate system from the one that's in the file to one that can work a little bit better on our computer. And of course, after everything is done and saved, it will always send it back to the original coordinate system, so there's no loss in precision or accuracy. So we're going to hit yes to all on here, and the points have been loaded. And the log window here at the bottom can give you some information about everything that was loaded. You can see how long it took and that it was loaded successfully. But at this point, we don't need this log window, so we're going to exit out of there. And here we have our point cloud. You can see that it's not looking like what we're used to seeing because this is actually shown in the top perspective and the actual scalar field or the information that's being described here is just in one color. You can click with the the left mouse button here and rotate, and you can see that we are moving around the axis in the center. And as you move around, you have to get a little bit used to navigating in Cloud Compare. So the easiest way to think about it is if you drag the mouse and you follow the blue circle, you will go in the direction of that circle, and vice versa with the red and with the green. But to make things a little bit easier to see, let's go into the tree last file. So this is the file that contains all of these points, and you can see as we click, these points get a yellow bounding box surrounding them. And as we click here, we also see the properties window appear under us. So you can click and drag this up, and you will see that our point cloud right beside us here has a few properties. So right off the bat here, we can see the total number of points. So there's 10 million points that comprise this cloud. To navigate, you may need to double click. That will change the center point. But at this point, we don't really need to navigate very much because all we're going to do is change some of the settings here so this becomes a little bit easier to see. So let's look at some of the available fields. So in the first column here under colors, RGB, we don't have any RGB image, information in this point cloud. It was never colorized. So we're going to switch this over to scalar field. And these are those fields that are contained within each point as an attribute. The first scalar field that appears is an intensity. So we can see here in grayscale the intensity of the return laser. Obviously this is of a forest canopy, so the intensity of the laser hitting the leaves at the top of the canopy will be stronger than those that are hitting the forest floor. So we see what we expect to see in this range. We can change the color scale over here under gray. We can change it to blue, yellow, blue, green, yellow, and red. And you can see in the histogram here the distribution of the points according to that intensity. So this is another way of seeing that relationship. And then you can always create your own or switch through these, but essentially intensity is usually identified as grayscale. This is good enough to identify any of the features that you may be able to see in here. The other one that we want to take a look at first is GPS time, and we can see here the start and the end of the scan. So we see that overall the drone basically started at this corner and flew across to this end over here. That's how the mission was, or the data was collected. So this is great, but the one that we really want to see is height. We want to see the points that are higher and the points that are lower. In a canopy height model, we also want to see the difference in tree height relative to the ground. So first, let's take a look at absolute height values for this grid. So I'm going to bring this to the center of my screen and zoom in a little bit so you can see a little bit better. Here it is. And that height information currently isn't visible because it has to be made its own field. So what I mean by this is these scalars, these pieces of information that are within each point. And as you saw here, we have some scalar fields, and the display of the scalar fields is what we see and active. Right now we have intensity essentially. We want one of these to be for height. So we don't really have one to begin with, so we're going to make our own. So the first thing we're going to do is select the point cloud, make sure it's selected. We can only make changes to something that we've selected. So we see that this is highlighted and we have the yellow box. We're going to go over to Edit, Scalar Fields, and down this list there is one right here called Export Coordinate to Scalar Field. We click on that and we get this dialog box. And this is going to tell us that we are exporting the z coordinate for each point. Remember, each point has an x, y, and z, but we want to take the z coordinate and we just want to show it as its own field. It's not actually going to affect the cloud in any way. It is just going to give us another way to view that data. So we're going to hit OK. And as soon as we do that, you can see that the point cloud has changed in color a little bit. And as we zoom around, we can see that the lower points here near the ground are blue, and the higher points at the top are red. So this is exactly the same color scale that we had selected here: blue, green, yellow, red. And then this histogram here also shows us the relationship and the distribution of those points. So the x-axis going across this way represents the altitude, right? This is from GPS, so this is going to be the ellipsoidal height unless it was changed. But we can see that the lowest point in his data set is at 257.82 meters, and the highest point is 299.61 meters. So these units, they don't display meters, but you can assume that they come in the units that this file was created in, and we're going to assume that that is meters, as it's most commonly around the world. In this histogram, we can also play around with how these colors scale. So we have this triangle here, and we have a triangle here, and we also have this little circle and the little circle. And you can see that these can be dragged. And as I drag the circle, you see that the display ranges change. So we can set it to only display a specific altitude. And as you can see, as we do that, points that are outside of that altitude go gray. And in fact, if we go under here to parameters, we can uncheck this, show not available or out of range values in gray. And if we uncheck that, then now those points that are not available are not displayed in gray, but they're actually just completely eliminated. They're just hidden. They're not deleted, but they're hidden. And you can see that we can quickly segment things out of this point cloud and only see a specific height. So if we want to see a height down here by the tree forest floor. Then we can drag these two sliders to show only that range. Or if we want to see just the tops of the trees, then we can bring this height up and you can see just the highest tops of the trees. But the problem here is that the floor of this forest is not flat. There is elevation to it, so we can see from the top or from the bottom, but as you look at the side, and we show all of the data here, you can see that parts of this are low, parts of it are high. And we look at another angle here from the side, you can see that the floor changes in elevation. This height scalar field shows all of the heights in these points in absolute terms. So we see the very lowest to the very highest, but it does not show us the height of the points relative to the ground. So if something is just a meter above the ground, it should be a meter above the ground here, but also up here should be a meter above the ground. We don't know the difference between the ground and everything else. This is just one full data set with respect to the height of the GPS at that point. So this isn't going to show us what we would refer to as a canopy height model. To do that, we need to separate these two things out. We need to separate the ground elevation, and then we need to compare the ground elevation to all the other points that are not related to the ground. And that will show us a measurement of height for each individual point, which represents the tree canopy, because of course this only contains trees in this data set. So over here on the histogram, another thing we can do is play with these triangles. These change how the color pattern is distributed across these trees. So we can show colors ranging from that blue to red for only a specific strip like that, or we can show it for the entire data set by bringing these all the way out, which is how we'll leave it for now. Okay, so the first thing we need to do then is separate the ground. So let's filter out what we have as ground points. So in order to do that, okay, we're going to click on the tree.las file as well in our database, and then we're going to go up to plugins, and we're going to select this plugin right here. This is the cloth simulation filter. So this will simulate what it's like to throw a cloth on the underside of the data set, and that cloth should represent the ground. And everything that isn't on that cloth would represent anything that's off ground. So another way of describing this is if we turn on a way of looking at this, you can see the trees up here, but as we flip this around, like so, this is the ground, right? So this is the terrain. So if we draped a cloth or threw a bed sheet essentially over this, and these points held that sheet together, then we should get a surface that reflects what the forest floor looks like. So essentially what this plugin is doing, it's inverting the data set like this, and it's simulating a cloth. That's why it's called the cloth simulation filter. Now we don't have to do any of that. It does it all for us. So all we have to do is go over to plugin, click on CFS filter. In the pop-up, select the type of terrain. Of course, this is relief. We have a little bit of an elevation change. We're going to go to advanced parameter settings, and we're going to change some of these parameters so that we get good results. First thing we're going to do is we're going to reduce the cloth resolution. So this is how fine that cloth is. And these units are in the units of the data set or the point cloud. So this would mean a cloth that has a resolution of 2 meters, or it's made of 2 meter squares, essentially, like a big patch. So we're going to reduce this to a number that's fairly low just to give us some granularity. Let's use 0.5 meter. Iterations is how many times it goes through this to simulate it. We'll just leave it at 500. And then the threshold has a good description here, refers to the unit that is used to classify the point clouds into ground and non-ground parts based on the distances between points and the simulated terrain. So essentially 0.5 is the most adapted, and we can leave it as this and see how this works. We can always try this multiple times by just changing this up and down and then running it again and see what difference it makes. Another thing I'm going to select here is export cloth mesh. This is useful because it will help us visualize, and we can use this mesh later on. So I'm going to click on cloth mesh, and I'm gonna hit OK, and it's now gonna start computing. This can take a little bit of time depending on your computer and the data set, but this is a fairly small data set, so it's pretty straightforward. So now that we've completed, we see that we have a few things that have been added. We've added the cloth at the bottom, but then also if you pay attention to the database here, the files, the file that we brought in, tree, has not been affected, but it has been unchecked. Unchecked means that it's not visible. But there has been a new data set that's been created with the underscore CFS appended to it, meaning that we've applied this filter to it. And this shows us that we now have ground points, off-ground points, and mesh in this data set. So there's now 3 components. And we can start to uncheck these. So if we uncheck off-ground points, you'll notice that we have only the ground points remaining and the mesh. And if we remove the ground points off here as well, then we have just the mesh. So this is a representation of what that terrain looks like. And you can start to see the features in this terrain. There's a depression here, right? It looks like it could be a stream or a creek, and that's very visible. As of course we have the ground points as well. We can hide those and just show these points. These are points that represent the ground. This is of course what that cloth would have rested on to create itself. And you can see that there is a little bit of height in here as well, right? There is generally some grass or some vegetation, some brush at the bottom of the forest, so we can't expect this to be completely flat in any case, even if we were there on foot. Moving on, the off-ground points look pretty good. Looks like we have a good selection of them, and all of the trees that we are interested in are there, and there are no trees in our ground points. Now let's go back to the mesh, and you can see these lines. These come from the scanning laser itself. So sometimes there is some separation between points, and we can't avoid this stepping that's happening here. This is only one flight swath, so one pass with the drone. Usually you would have some overlapping passes to be able to fill these features in. So let's try another set of settings. So I'm going to go over here and just delete these outputs. I'm going to right click on the tree folder, and I'm just going to delete. But remember, we always have our original point cloud right here, so as soon as I check it on, it goes back on. So I'm going to select it again, go to plugins, select CFS filter again. Here's my CFS filter. I'm going to leave it at relief, go to advanced parameter settings. I'm going to drop my cloth resolution to 0.2, make it a little finer, maybe 0.3. And then I'm going to drop my classification threshold a little bit to 0.3. And I'm going to do the same cloth mesh export and hit OK. This should take slightly longer because we're using a higher resolution, but it could produce some better results. So let's take a look what it did. Let's remove the off-ground points. There we go. And let's remove the ground points. And we can see we got a little bit more detail. We can now start to make out that there's probably a little path coming through here that's been walked right there. And you can see that the ground points, again, a little bit more detail in those ground points. A little bit more of the holes have been filled. You can even see a little tree trunk that's fallen over right across here. Okay, so at this point, we're almost ready to do our canopy height model where we're showing the relative difference between the height of the trees relative to the ground. So the ground is always going to be 0, even though you can see here that the ground has elevation on by itself, but we want the ground to basically remain as elevation 0, and then measure every height, every point, its height above that ground, so relative to the ground. So we're going to uncheck the ground points, and we're going to check off the off-ground points. Here's our trees. This is what we want to measure. And we have to have 2 things to measure against. So we're going to use this as the what we're measuring, and then we're going to use the mesh that was created by our CFS filter as our reference. So this is essentially going to be our 0 line. The reason we need to use a mesh is that the mesh is one vector, so it's one line essentially. It's one surface in space. Whereas if we use the off-ground points, these points, you can see there are many, but on the ground points there are fewer, but they also don't create a surface. This isn't a watertight mesh. So any points above the ground in our off-ground points that don't relate to a space where there's ground points, we wouldn't be able to measure them. So we're going to use the mesh that's already been created. We don't have to create this again. And you can see as I move the mouse, there is a reflective property to this, so you can see how light is simulated to bounce off of it. That means that this mesh also has normals, and normals is the direction of the face. So we know, based on how the lighting is working, or the computer knows, that this face here, for example, is pointing up, this face here is pointing sideways, etc. So this is very useful to know because that allows us to measure distances with respect to the direction of that face. We know that this is underneath or under the surface, and this is above the surface and pointing up. So to do this measurement, we're going to select both our points. So we're going to show our off-ground points and our ground points. We're going to select them both by holding Control and pressing on both, clicking on both of them. And we have both of them highlighted. And now when we have both of them highlighted, you'll see this icon appear right next to it. So this is the compute cloud to mesh distance, right? And we have compute cloud to cloud distance, and there's a few other things here, but this is the important one, the compute cloud to mesh distance. So we're going to measure the distance between the points and the ground, which is our mesh. Okay, so we've done that, and once you click on it, you get this computation dialog that comes up. We're going to select some general parameters here. We're going to leave everything as auto on the levels here, and we're going to use sign distances. We're going to do multi-threading, so we're going to use all of our CPU cores to do this. And under local modeling and approximate distances, we don't need to change any of these. These are all ready to go. The important thing is that we're going to compare the off-ground points to the reference mesh. And we're going to hit compute. Now, this can take a little bit longer if the data set is a lot larger. Okay, so that's done. Let's hit OK. And now we'll have basically the same thing, but the properties of our two data sets here have changed. So we can uncheck the mesh and take a look at our off-ground points. And here in our off-ground points, under scalar field again, we'll see this new scalar field called C2M sign distance. So cloud to mesh sign distances. So this represents the distances between the points and the mesh. So this obviously starts at minus 15, which should be an error. Let's return this back to 0. And you'll see where essentially the distance between points and the mesh are 0. And then we can see that the highest points recorded are 25 meters above. So we can bring the circle as well to 0, just so that we hide everything else. And that's this box up here. So type in 0, hit enter. And under parameters, we're going to uncheck this so that it doesn't show those in gray to make it a little easier to understand. And now you can see that when we have a side view of this point cloud, the points are all related to the ground. They're no longer hitting that red because they all start at 0 where the ground is, right? So now this is effectively our tree canopy height model, so the height of each individual tree in this data set. We can play with the colors as well. We see that there are some outliers. There are some points that are just floating in space, such as these ones. We can hide those or just display them differently by bringing the triangle back down. And this will change that range of color. And we can see now that the red tops of the trees are pretty evenly distributed through the entire data set. Other than that, here's what it looked like when we didn't have any of this. So you can see that these trees are relatively lower to the ground than these trees. So you only see the elevation show that red distance up here, whereas in our new data set that's been normalized and made in relation to the ground, we see that the tallest trees are actually in this section, not in this section, right? So if we go back, you would say, the taller trees are here, but in reality, the tall trees are over here. So we can switch back to this view and look from the top down, and gives you another representation of what this looks like. And we can hide the mesh here, and you can see that the treetops are very obviously delineated, whereas we go back to our original, and you see that everything kind of looks like it's in the same height in this section, where it's actually very different. You can see the tall trees and the lower trees. And another way to look at this is to select our off-ground points and maybe also select our ground points or our mesh. Let's do our mesh instead. I'm going to select both of these, holding Control and clicking on both, so they're both highlighted. You can see them right here. And then now I'm going to go over to the segmentation tool, which is this tool right there. So I'm going to click that, and this shows a few little icons. But what I'm going to do is I'm going to grab this blue one, the donut. I'm going to use this to rotate it around. I'm going to rotate it so that it fits these trees, the length of the swath. And then I'm going to start to cut the other one, bringing it in like this, and bringing this one in like this. And you can see that we are cutting through everything else. And I can look at it from the side, and from the side you can very clearly see how this canopy height model works. So again, the side here, this front, and then side view. I'm going to hide these borders. And you can see as well that we have segmented the height of the trees relative to the ground, and for the ground we are using that mesh. Okay, and switch it back. And now it's important to understand that this is also information that lives inside of this scalar field. So of course you can show only the heights that you want. So let's see only, for example, trees that are above 10 meters above ground. So we type this in as 10. And then you would only see the points that are 10 meters above ground. right? And you can hide this, bring this all the way up. Let's see the highest tops and the lowest tops. So you can see kind of when these tops start to disappear. I'm going to scroll it back the other way too, right there, and we can see where they all start to finish. You can see probably the highest tree is this one right there, all the way through. And hide the mesh. So it looks like the tip of that is at 18 meters. So I'm going to show, for example, between 0 and bring this down to about 18. Go. And that should be all of the points relative to the height. Now, one final thing we can do to visualize this a little bit differently is apply some shading or simulate how light would fall through these. So that's another filter here that we're going to use just for visualization. We're going to click on off-ground points. We're going to go to plugins, and we're going to use the PCV Shade Viz. And we're going to do a resolution of 512 to make it a little bit lower, and hit OK. And this is going to simulate what it would look like if there was a sunlight or a single light source at the top, casting shadows. I'll let this run a little bit. And there we go. And you can see here in this view, you can really clearly see the tops of the trees. And as you look through the middle, you can also visualize how dense that canopy is. Pretty cool, right? And again, you can use this tool to take a slice out. Right, there are the tops as well, and display it on its own. Okay, and that's it for today's tutorial.